I'm a carbon-based life form. You're a carbon-based life form. We eat carbon, exhale carbon. Our homes, transportation, and economies are built on carbon. We need carbon, but maybe too much. How does carbon flow in and out of wherever it's currently hanging out? We'll find out together in this episode all about the carbon cycle. Most of Earth's carbon, about 65,500 billion metric tons, is stored in the geosphere, inside rocks. The rest is in the ocean, atmosphere, plants, soil, and fossil fuels. These storage containers, if you will, are called reservoirs. Carbon flows between each reservoir in an exchange called the carbon cycle, which has fast and slow components. It is important to note that any change in the cycle that shifts carbon out of one reservoir puts more carbon in the other reservoirs. It has to go somewhere. Through a bunch of chemical reactions and tectonic activity, carbon takes between 100 and 200 million years to move between the atmosphere, rocks, soil, and ocean in the slow carbon cycle. The movement of carbon from the atmosphere to the lithosphere begins with rain. Carbon in the atmosphere combines with water to form carbonic acid that falls to the surface of the earth in rain. This acid dissolves rocks in a process called chemical weathering. This process releases things like calcium, magnesium, potassium, and other things that are stored in rocks. The flow of water then washes these ions into rivers, then out to the ocean. In the ocean, the calcium forms calcium carbonate. Shell-building or calcifying organisms, such as corals, sand dollars, sea stars, sea urchin, and plankton, use calcium carbonate to build their outer protective layers and shells. After these organisms die, they sink to the seafloor. Over a long time, layers of shells and sediment are cemented together and turned to rock, storing that carbon in limestone. 80% of carbon-containing rock is made this way. The remaining 20% contain carbon from living things, or organic carbon, that have been trapped in layers of mud. Heat and pressure press down and compress the mud and carbon over millions of years, forming sedimentary rock. When dead organic matter builds up faster than it can decay, layers of organic carbon become things like oil, coal, and natural gas instead. So it makes sense that we call these fossil fuels. The slow cycle returns carbon to the atmosphere through volcanoes. When tectonic plates collide, one sometimes sinks below the other, and the rock it carries melts under the extreme heat and pressure. The heated rock releases carbon dioxide, which is then vented back to the atmosphere when the volcano erupts to begin the cycle again. The time it takes carbon to travel through the fast carbon cycle is measured mostly in a lifespan because it is largely movement through the biosphere. Carbon molecules are an excellent source of fuel for all living things. Plants and phytoplankton are the stars of the fast carbon cycle. Phytoplankton, or microscopic organisms in the ocean, and plants take carbon dioxide from the atmosphere by absorbing it into their cells. Using energy from the sun, both plants and plankton combine carbon dioxide and water to form sugar and oxygen in a process called photosynthesis. Carbon can cycle from a plant back to the atmosphere in one of 4 ways. Plants break down the sugar to get energy that they need to grow. Some carbon dioxide goes back into the atmosphere. I know. Plants release mostly oxygen back into the atmosphere, but they do release some carbon dioxide as well through respiration. Consumers, all types of animals and humans, eat the plants or plankton and break down that plant sugar to get energy. The carbon is returned through respiration or waste. The plants and plankton that are not eaten then die and decay, or fire consumes the plants, releasing the carbon directly back to the atmosphere. The fast carbon cycle is so tightly tied to plant life that seasons like winter and spring are measurably different in the concentrations of carbon dioxide in the atmosphere. During the northern hemisphere winter, when few land plants are growing and many are decaying, atmospheric carbon dioxide concentrations rise. Then, during the spring, when plants are thriving and growing again, concentrations drop. It's like the earth is breathing. If you're still here liking this video, let us know and hit that subscribe button so you never miss an episode. If left alone, the slow and fast carbon cycles would maintain a pretty steady concentration of carbon in the atmosphere, hydrosphere, biosphere, and geosphere. But when something changes the amount of carbon in one reservoir, there is a ripple effect throughout the others. The current changes in the carbon cycle are happening because of human impact, removing carbon from the three main carbon sinks on Earth: the forests, ocean, and soil. When we clear forests, we remove a dense concentration of plants that have stored carbon in leaves, stems, and wood, their biomass. This is extra impactful because we are at the same time eliminating plants that would otherwise pull carbon from the atmosphere as they grow. Without plant cover, soil is also venting carbon from decaying plant matter into the atmosphere. Without human interference, the carbon in fossil fuels would still leak into the atmosphere through volcanic eruptions in the slow carbon cycle. By burning coal, oil, and natural gas, we accelerate the process, releasing carbon that took millions of years to accumulate into the atmosphere every year, moving carbon from the slow cycle to the fast cycle. All of this extra carbon in the atmosphere has to go somewhere. The ocean and plants seem to have taken up about 55% of this extra carbon, while about 45% has stayed in the atmosphere. Over time, land and the oceans will continue to absorb the extra carbon dioxide, but 20% or so may remain in the atmosphere for thousands of years. Carbon dioxide is a greenhouse gas that absorbs energy, including infrared energy or heat emitted by the Earth, then re-emits it. This energy travels out in all directions, some returning to Earth, where it heats the surface. We need greenhouse gases. Without them, Earth would be a frozen wasteland. But with too many, Earth gets too hot, and that isn't good either. The ocean absorbing carbon dioxide helps out the atmosphere, but it creates a more acidic environment for marine life. These warming temperatures are mostly a concern where frozen soil or permafrost is thawing. Permafrost contains vast deposits of carbon from plant matter that has accumulated over thousands of years. The cold temperatures extremely slow down decay. If decay speeds up, the carbon dioxide seeps more quickly into the atmosphere. There are so many little choices that we can make every day to positively impact this carbon cycle. Something as simple as planting a small garden in your backyard or trying to eliminate food waste can help. There's a link to more ideas somewhere down there. And if you want to learn more science, you can check out this video next. Natural gas.